Okay, let's play a game.
From Hollywood, the entertainment capital of the world.
Biologist Sarah Zielinski took these shots, and if you needed a helping hand to find the cuttlefish, don't feel bad.
I've certainly taken photos in the past, then come back to look at them and gone, I'm sure there was a cuttlefish in there somewhere.
These cephalopods are master camouflagers. But while they're hiding their body, they're revealing something about their mind, or at least their visual system.
In very simple terms, they can tell us what they can see via the body patterns they produce on their skin.
They produce these body patterns by expanding or contracting chromatophores, these little ink sacs on their skin. And they use different displays for different reasons, like for male-to-male combat.
Two males will turn into each other and pass these kind of waves of dark chromatophores over a really bright, sort of iridescent, stripy body pattern, and somehow solve these these combats. Eventually one male, gives up and goes away.
And then there's this unsolved mystery. It changes color when it grabs a snack.
That doesn't make perfect sense because it seems to make it very conspicuous. So one theory is that, it's just a happy signal of how excited it is to have caught something, some response that it doesn't have any control over.
But most of the time, they seem to be using their chromatophores more intentionally, primarily to blend in.
Because otherwise they're more likely to be eaten. So it's very important they don't make mistakes about ambiguous visual information.
And ambiguous visual information is specifically what Zielinski's interested in. So here's the experimental setup. Print out laminated patterns like this checkerboard and stick them in a tank.
And we place the animals in the tank and we record the body patterns that they produce.
You're seeing them on squares, but they do the same thing on top of circles. They produce
the disruptive pattern where you get these blocky components, sort of high contrast components.
But when you put a cuttlefish over squiggles, it produces a
sort of mottly pattern where you get these little groups of dark spots showing across the body.
So what happens when you put a cuttlefish on something in between? When you put them on incomplete circles? When we see something like this, our visual system likes to fill in the blanks. Something we do constantly, Zielinski says.
The reason why cartoons and sketches work is because we can recognize objects based on their edges alone.
And we can identify objects even if they're broken up or
have an object that is occluded by another object. That's no problem for us. We can still work out what the object is most of the time. And I was interested to know whether cuttlefish can solve similar problems. And
Zielinski and colleagues report this week that cuttlefish do seem to
fill in those gaps and interpret those little segments as a whole circle.
Or anyway, the broken circles prompted the same camo pattern as full circles. So if you're wondering, I see these as circles too, what's the big deal? The weird thing here is that there's no reason why cuttlefish, which are
invertebrates and they're in the same group as slugs and snails,
should see the world the way we do.
Yes, it's like they're alien, but we also seem to have so much in common with them.
So, the next step?
Because we can't share the perceptive experience of a cuttlefish, it's hard to know exactly what it is that they're doing to fill in that missing information. And I want to try and get a better grasp on that and also see whether they actually respond to true illusory contours.
So you're going to show optical illusions to cuttlefish?
That's what I'm hoping to do, yes.